Hello students, hope you are doing well. So in this lecture, we will just see the practical implementation of this pointer with the help of a program. So I have just created a class sample. Okay, so inside this I will be creating a variable, okay, of type int. Okay, and in the public section I'll be creating a method. Let's suppose the name of the method is set, and inside this method I have taken a local variable of type integer, that is x. So I'll be just assigning this a. Okay, so this a will take the value of x. Okay, x has been assigned to a, and I will just write a statement inside this. Okay, so the statement will be like address of current object pointed by this pointer is. Okay, so this will be this. Okay, so this is a keyword that, okay, contains the address of the object, okay, that we will be creating, and a new line. Okay, so now I'll be creating a method show, okay, that is used to print the value of the data member a. Okay, so I'll be just writing inside this cout value of a is, and it will be a. Okay, and I'll just give new line. Okay, so in the main function, okay, we will just create certain objects of type sample. Okay, so let us suppose s1 and s2 are two objects of type sample, that is a class, and I'll just assign, okay, certain values to the method of this particular, okay, class. So I'll just write s1 dot set. Okay, so s1 dot set, and I just assign a value, let us suppose 20. Okay, and at the same time I am just printing, okay, the address of s1. Okay, so address of s1 is also being printed, so this will be ampersand s1. Okay, and a new line. Again I'll just call, okay, the current object s2 on the method set. Okay, so now this will be called on the method set, and let us suppose the value passed is 30. So again I'll just repeat this particular statement for s2 also. Okay, so it will just print the address of s2, and it will be ampersand s2. Okay, so at last I'll just invoke s1 dot show to print the value of s1, and s2 dot show to print the value of s2, that is to print the value of a in s1 and to print the value of a in s2, because now a is, okay, a is the data member that can be invoked by, okay, both the objects with the help of this particular member function, because a belongs to both these objects. Okay, and we have to print the address of these objects also, and we have to verify that, okay, whether the address of these objects are, okay, coming same or not when we are trying to, okay, use the concept of this pointer. So when, okay, when this particular s1 dot set call will be, okay, completed, okay, during the compile time, so this, for this particular s1, okay, this method has been invoked set, and inside this set method, okay, inside this set method, this pointer will be activated, and now this pointer can see that yes, this a is a data member. Okay, this is a data member, it belongs to a class, this is a member of a class. So this a is now replaced by this arrow operator a. Okay, so now we haven't, okay, we haven't replaced this particular a as this arrow operator a, but implicitly compiler will replace this particular statement as this arrow operator a is equal to x. Okay, okay, we can also do it explicitly, but now here the compiler is doing the task, and in the next line it is, okay, it is just printing the address of this particular object. So here this is a keyword that is used to print the address of the current object. So for the first case, the current object is s1, so here this will contain the address of s1, and the address of s1 will be printed. Okay, and this, and s1 dot show will print the value of a, that is 20. Again when I'll be calling, okay, the method s2 dot show, so for that particular s2 will be the current object, and the address of s2 will be stored, will be pointed by this particular pointer, and the value of a in s2 will be, okay, retrieved through the function. So let's try to execute this program and let's try to check for any errors. There are no errors, so let's try to execute it. So here you can see, okay, address of current object pointed by this pointer is, okay, 0x22fe4c. okay, so this is the address of the current object, that is s1. okay, so for s1 the current address that is, okay, pointed by the this pointer is this. okay, so this is the address that is, okay, that is contained in the this pointer of the current object s1. So you can just map this address with this address. okay, both the addresses are coming same. okay, so this is also 0x22fe4c and this is also 0x22fe4c, and the address pointed by this pointer is, so this is the address of object s2 and this is 0x22fe48, and also you can just verify it. okay, in the main we have just printed the address as ampersand s2, so this is also coming out to be same. So the main, okay, the main you can say concept is we are just analyzing that this pointer will contain, okay, the address of the current object. okay, in spite we are, okay, we are explicitly calling this pointer or we are explicitly writing this pointer in our program or not, but it contains, okay, it is present in all the non-static member functions. okay, if I am saying non-static member functions, it means the member functions of a class. okay, I am not talking of friend function and I am not talking of static functions, because for this static functions and for friend functions this pointer won't work. okay, so here we can cross verify also. So the object, the address of the object s1 is this, okay, and this pointer is also pointing to this. okay, both are same. Similarly the address of s2 is this and this pointer is pointing to this, and the value of a is 20, this is for s1. okay, and the value of a is 30, this is for s2. okay, so this verifies the concept. So if I just, okay, if I just change this variable x to a, okay, and I just write a to a, okay, so now what will be the problem? okay, so as we know that in the programming, the if we are creating any function, okay, and inside a function the priority will be given to a variable that is a local variable. okay, so here in the function set this a is a local variable, okay, and during compilation the compiler will see this a as a local variable. okay, this a will be seen by the compiler as a local variable, not as a data member. okay, so for this particular call, okay, for this particular statement the compiler implicitly won't replace this a as this arrow operator a. Why it is not replacing? Because now the compiler is seeing this a as a local variable inside this particular block. okay, this a has been hidden. okay, this a has been hidden from the compiler. okay, the compiler doesn't know that this particular a is same as this particular a. okay, but in spite of this, for the compiler, this the a that is present in the left hand side, this is a local variable. okay, so the compiler is assigning a local to a local. okay, so a will be assigned to itself, a local variable of the block will be assigned to a local variable, and the data member a will be ignored by the compiler. okay, so when this type of problem arises, so the compilation will be, okay, proper, there will be no error in the compilation, but the result will be, you can say, some ambiguous type of result. okay, some garbage value will be printed. Why the garbage value will be printed? Because if I am trying to print the value of this a, so this a contains nothing. okay, because nothing has been initialized to this a, because the compiler hasn't seen this particular a. okay, the compiler has only seen this a as a local variable. okay, and this a has not been initialized yet, so there is some garbage value that has been printed by the compiler. okay, so if you try to just execute this program, okay, if you try to compile this program, so you can see there is no compilation error. But when we try to run this program, so here you can see the value of a is 0, okay, and the value of a is 16. So there are some garbage values that have been printed by the compiler. okay, we have passed the value of a as 20 and 30. okay, we have passed the value of a as 20 and 30, but it's printing the value of a as 0 and 16. okay, because the initialization problem is there. Why? Because the left hand side a has been, okay, read by the compiler as a local variable, and local has been assigned to local, and that's why the value of a is not being retrieved by the compiler. So in order to resolve this problem, okay, we can explicitly write, okay, the left hand side as this arrow a. So if I write this statement explicitly as this arrow a equal to a, so the left hand side, okay, now this left hand side okay, will be read as a data member. So this statement will be read by the compiler as the local variable is assigning the value to a data member of a class, because this pointer contains the address of the current object and the object contains the data member in itself, okay, because object contains data member as an attribute. So for the compiler, this a is now an attribute of a class or an attribute of an object, and this pointer contains the address of the current object. So now this left hand side will be read as a data member. So now this particular thing will work properly, and now the compiler will, okay, print, okay, the correct value of the data member a. So if we try to just execute this code, okay, so you can see there are no errors, okay, and during execution now you can see the values of a and b are coming exactly the same that we have expected. That is, the value of a is 20 and the value of a is 30. So it means now we have explicitly told the compiler that this a is not a local variable, this a is a data member, okay, with the help of this arrow a, okay, with the help of the member access operator arrow. Okay, so now in this way the working of this pointer is there in a program, okay, and you can see that both the addresses of s1 are same and both the addresses of s2 are same, okay. So this is, you can see, a constant pointer. It can point a single address at a time, okay, it is not pointing to multiple objects at the same time, okay. So this is also a valid statement. So if you try to, okay, execute this code, so the answer will be same, there will be no difference in the answer, okay. So this is also a method of writing or of invoking the data member with the help of this pointer. So I hope now this concept is clear. Thanks.